I'd like to introduce John, W6MBC. Just to give you a little bit of a bio on John, John was licensed in 1965 and he passed his extra in 1972. So a very experienced amateur radio operator. He holds a couple of commercial licenses. He has a degree in physics from Oregon State University. So not many people have degrees in physics, so that is an achievement by itself. John used to be a television broadcast engineer and an instructor, and he's now retired. He's done over 35 articles to date for the ham radio magazines, for example, QST and OTA. He does a lot of presentations and experimentation, allowing him to do these presentations, which is awesome that we can tap into that expertise. He's active on everything, including ham satellites. He lives in LA, California. He was living in the UK for 10 years and has a call sign in the UK of Mike 0 Golf Charlie Kilo. He's married with 3 children and 12 grandchildren, and his wife is also amateur radio. Loves steam railroading, pipe organ, sushi enthusiast, and it looks like he was into radio control airplanes when he was younger as well, John. But let me not hold it further. Let me hand over to John, and thank you for your time this evening, John. Appreciate it.
Oh, it's my pleasure, and I want to belatedly extend an apology for missing the last couple of times. We got all messed up. You can imagine now I've passed the 250 mark, a quarter century mark in making these Zoom presentations to radio clubs around the world. I've spoken in pretty much every English-speaking country in the world, although I haven't spoken in India yet. Of course, it's questionable whether India's English-speaking or not.
A lot of them are English-speaking, yes.
Yeah, anyway. But New Zealand and Australia and Tasmania and so forth, they've all had me speak. Anyway, this particular topic, which is an interesting one, like I say, kind of started almost as a bet, and yet it was quite a revelation when I found it. So let's go over there and start it up here. And close down a few things here on the screen and get that out of the way. Okay, and go to the slideshow and from the beginning. All right, you should be, see if I can move it.
All good to go.
I cancel here. Okay, very good. Okay, you should be looking at your the opening slide here of the presentation. Is that correct?
That is correct, John.
Okay. And by the way, I'm going to point out at the bottom of this screen here that these slides that you're looking at are all downloadable if you want a copy of them. And you're free to use them as you like in your own presentations if you wish, or if you want to put them up on the internet, you're quite welcome to it. I don't, my material, I like to make it open source because they're just here to help the ham community. So I don't mind if they get put about, but you can download them if you wish. The slide deck here from w6nbc.com, that's my website. If you just append /slides to it, all of my PowerPoint slides are available up there. Let's get this up here. Now, open wire line is a kind of a mystery to hams. It's used, of course, and fairly popular to some hams. But I'm going to talk to you about where open wire line has never gone before for most hams, because most hams have a kind of a feeling that it's a limited type of transmission line that has to be used rather carefully or it won't work right. And I'm going to show you today that that's just really not true. So we're going to take you to where open line has never gone before for most hams, a la the Star Trek Enterprise here going off into some strange distant planet off in the universe somewhere. Of course, we all know that in the early days of ham radio, in fact, most even commercial radio, open wire transmission line was the order of the day. As we can see here, here was a station, probably a U.S. station in the early days, before even prefixes were on call signs, before the 1910 conference that pretty much put prefixes on the front of call signs. Most of us had call signs, that hams had call signs that began with a number, like this station here, 3ABT, probably became W or K3ABT after 1910. And I imagine this particular operator here, probably working AM at that time, uh, probably used open wire transmission line to get his signal out to his antenna. He probably didn't have a rhombic, as this particular drawing shows, but I'm sure he probably used open wire transmission line because it was pretty much the dominant form, even for professionals. But open wire transmission line is not gone by any means, even in the professional world. Here's a broadcasting antenna tower, probably an AM medium wave transmitting tower. And the transmitter is not at the base of the tower, probably some distance away. And whatever this installation is using open wire transmission line, a multi-wire open wire transmission line in these interesting frames to get the signal out to the antenna with very low loss. And of course, that's the joy of open wire transmission line and why some hams like to use it, because of its low loss characteristic. I'll mention right here, but I'll say it several times through this present line. Open wire transmission line is not lossless. It has loss, but just less loss than coax, which is what we tend to use today. Today, however, as I say, we prefer to use coax because it has several advantages over open wire transmission line, which we'll get into here in a minute. But we might ask ourselves, why did we make the changeover from open wire transmission line for most hams, and even commercially especially? Why did we make a changeover from open wire transmission line, which works very well and is quite low loss, to coax? Well, it all started in the Second World War when the shielded properties of coax were very advantageous, and they still are today, and that's why we use it primarily for its shielding properties, particularly a couple of German soldiers in the trenches. Open wire transmission line wasn't very handy for mobile radio applications during the Second World War, and coax really came on strong during that time, as well as a lot of other radio technology. The Second World War probably pushed radio forward more than almost any other single world event, but it certainly pushed coax into the forefront and pushed open wire transmission line kind of into the background, particularly for hams. It was in 1945 when the company Amphenol began advertising in the American magazine QST. And here's one of their ads from 1945 showing one of the first ads for coaxial transmission line. And we began to offer it to hams. And of course, it was being offered into the commercial radio world too, which picked it up wholesale because of its shielding properties, both from shielding other stations from your signal going out and shielding your station from other signals coming in. And coax has been the dominant form of conducting RF around ever since, although open wire line hasn't gone away. It's still in use, particularly for hams, but even for commercial applications, as I showed you a minute ago. Many hams have even made open wire transmission line, like you can see here on the left. There's some homemade 600 ohm transmission line made with just some common house wire, looks like, and some homemade spreaders, which are held on, looks like little pieces of wire. Also, hams tend to oftentimes use 300 ohm television ribbon line, which was pretty dominant in the 1950s for bringing the signal down from TV antennas, which were on top of TV aerials on top of homes in 1950s, at least here in the United States. I assume it was true in South Africa as well. But 300 ohm TV ribbon cable was very, very common back then. More recently, for the ham community, 450 ohm slotted transmission line has been very popular, and I use it quite often. Another product which I like, which allows you to make your own 600 ohm transmission line, open wire transmission line, is a product called Ladder Snap. I'm not advertising. I don't have any interest in the company, but I like it. It's some little injection molded spreaders that you can buy in a bag for relatively low cost. I don't know if it's available internationally, but it's certainly available on the internet. And so they're little plastic spreaders that you can buy, and you just snap on 12 AWG size wire, and you've got yourself some 600 ohm ladder line. It's nice stuff. I keep a bag of it in my tool bins or my parts bins in case I want to build myself some 600 ohm ladder line rather than making it up out of 10 barrels or something else. Now, this is an interesting chart I want to show you to compare coax and open wire line, and an interesting point that'll pop up here. This is 100 feet of three common coaxes and two common open wire lines compared. It's all 100 feet here. And all of these transmission lines are properly terminated. That means they've got a proper terminator at the end, be it a properly matched antenna or just a resistor of the correct line impedance. If it's a 450 ohm line, it's a 450 ohm resistor. Or if it's 50 ohm line, it's a 50 ohm resistor. Or if it's not a resistor, it's an antenna that's been properly matched to that impedance. For all of the common bands that we're used to, 80 meters through 10 meters, as the HF bands, 2 meters, which of course very dominant, and 70 centimeters or the 440 band. And we notice the loss. Now this table here is the table you'll find published in most radio books. Radio books don't publish anything but transmission line that is properly matched. If the line is not matched, then the loss is much higher than this. But this is what the antenna books publish, is transmission line that is properly matched. And I want to point out a couple of things here. First of all, let's look at the small diameter coax that a lot of hams use, RG58. Poor coax. Notice how much loss there is in it. Even on 80 meters in 100 feet, you're losing, well, not a great deal. Probably on 80 meters, it's not too bad, but look at it up at 70 centimeters. You're losing 13 dB of signal in 100 feet. That's quite a bit. Even on 2 meters, you're losing 6.7, which is only a quarter of the signal is getting out the other end at 100 feet. RG8, which is, of course, really common in ham use, you're probably getting only half the signal out at 2 meters or a quarter out at 70 centimeters. LMR 400, which is really good 4/10 inch diameter or same size as RG8 coax, low loss coax, is about twice as good as RG8. This is what I tend to use if I want to use the heavier coax, same size as RG8, because it's about twice as good as RG8, but it has loss. 100 feet of LMR 400 on 440 is only letting about a quarter of the signal come out the other end at 100 feet. But notice 300 ohm ribbon cable right below it. A lot of hams think, oh, open wire line doesn't have any loss at all. Nonsense. Open wire line has loss. All open wire line has loss. 300 ohm ribbon cable, TV ribbon cable, has as much loss as LMR 400 coax. Look at it, compare the numbers. You can see it. It's so if you think that using TV ribbon cable is lossless, you're barking up the wrong tree or hoo-hooing up a hollow log, as they often say here in the south of the United States. 450 ohm ladder line, slotted ladder line, open wire line, is better. It's about 4 times better than 300 ohm, but it's still got loss. So don't ever believe that open wire line is lossless. It isn't. Hams, however, are afraid of, oops, stop that. Hams are afraid, though, of open wire transmission line because they're afraid that if they use it wrongly, that they're going to get into a lot of trouble. Well, my objective here in this presentation is to show you that that's not true if you use it correctly. And there are some steps you have to take to use open wire transmission line correctly. But I'm going to show you here today that if you use it correctly and you follow these steps, that you can use it almost anywhere that you can use coax. Maybe not inside of a radio, but at least out where you're going to use transmission line out to get your signal from your transceiver out to your antenna. You use it correctly. You can use it in situations almost anywhere that you can use coax. So if you want to take advantage of the low loss benefits of open wire transmission line, principally 450 ohm slotted line, these techniques will really help you if you want to make a long run for low loss. Many hams, though, still think that open wire transmission line or 300 ohm ribbon line has to be handled this way. It's either on the right, has to be completely out in open air like that, or it won't work right. A lot of hams labor under that assumption that they have to suspend it completely free of anything else. That's not true. That is absolutely not true. On the left, they think if they're using 300 ohm ribbon cable, ribbon line, that they've got to have it on standoffs. That is also not true. You don't have to have it on standoffs to make it work right. But a lot of hams labor under that misconception. Well, it's not wrong. That works, but that's not absolutely necessary. For example, many hams think you wouldn't ever lay open wire transmission line on top of a metal roof directly. You wouldn't ever think of putting open wire transmission line through a metal conduit. Or you wouldn't ever think of just running open wire transmission line over a metal window, right over the top of a metal window frame. You're afraid you'd get a terrible reflection if you did that. Or some hams are afraid to even put open wire transmission line through a stone wall like that, or even through drywall or whatever is in the house. They're afraid of doing that. But they certainly would never think of laying open wire transmission line right on the wet soil in a flower garden. That's a big no-no for open wire transmission line to most hams. But worst of all, no ham in his right mind would ever think of burying open wire transmission line in the ground. Well, this was the discussion I had with a bunch of hams at breakfast one day. I actually brought up the idea. I said, I wonder what would happen if you were to bury open wire transmission line in the ground. I wonder how bad that would be. I didn't know. I was like most hams and had all of these no-nos in my mind about open wire transmission line. But I said, I don't really know that that's true. I wonder how bad it would be. So I decided to go home that very day after breakfast and put it to the test and try and see what would happen if I did all of these baddies, all of these bad things. What would happen to my signal? How much would I lose? What would happen if I did all of these wrong things? So I asked the question, can we violate this common wisdom that so many hams carry around with them about open wire transmission line? And the answer is yes, we can. So I set out to find out with simple ham methods to debunk the myth that open wire transmission line can only be operated out in the open. And eventually I wrote an article which appeared in the American Journal for the ARRL, the QST, in August 2018, QST magazine. And this article ran there in the magazine, which if
which is available on the QST archive for anybody who's a member of the QST, on how to route 450 ohm window line and make it work right. Really, when it comes to open wire transmission line, principally 450 ohm ladder line, but it's true of other sizes of open wire line, but the really only practical open wire transmission line for most hams these days is 450 ohm slotted ladder line. So that's the only kind you can sort of go out and buy easily. There are only two musts, or only two to-dos. You got to keep it out of moisture. You don't want to let it get wet. And you want to keep it at a minimum distance away from the environment. What's that minimum distance? Well, I'll just state it for you right now. It's approximately as far away from the environment, anything, be it soil or metal roof or drywall or stone wall or whatever it is, as the thickness of the transmission line. So if it's 450 ohm slotted line, which is about 3/4 of an inch wide, it's got to be kept at least 3/4 of an inch away from the edge of the conduit, from the edge of the window frame, from the edge of the soil that you're laying it on, from the aluminum roof or aluminum roof. If you keep it away by 3/4 of an inch, it'll work just fine, and if you keep it dry. How do you do that? Well, first of all, let's talk about wetness. The first must do. I'm going to here's again a piece of 100-foot of open wire, 450 ohm open wire line, 100 feet of it with proper termination at the other end. Anytime you test these things, you got to have it properly terminated. Showing you the loss on a logarithmic scale here on the left. You see the loss in dB from 0.1 to 1 dB loss. That's what this scale of this chart is, showing you open this 450 ohm, 100 feet of 450 ohm line in 4 different conditions. Dry in the red, the green one is with frost on it, and the blue one is wet after it's rained. Notice how sensitive it is to being wet. This points out that if you want to use open wire transmission line, you want to keep it dry. That's a big to-do if you want to use it any place that you would use coax. Here's how you do it. Now, I don't know what's available for you in South Africa, so I can't speak it, but I imagine this is available to you. This is a material that you can buy at any hardware store here. I know it's available in the UK too, because I just made this presentation to a group in the Yorkshire Dells. And they said they have this same material. It's a cellular foam insulation that is used for heat insulating hot water pipes, copper or other hot water pipes in homes. You just buy it in 10-foot lengths, or maybe 3-meter lengths, whatever it comes in other countries. And you just slip it over the hot water pipe so that the hot water running through the pipe stays warm. And it's a good material. It's made out of polyethylene foam. It has a hole down the middle, which is just slightly over 3/4 of an inch in diameter. So it fits the slotted ladder line really very well. And it's made out of polyurethane foam. And it's called unicellular foam, meaning that the cells are not like in a sponge, which are open to each other. The little bubbles are closed. In other words, they're small bubbles. In other words, this foam is waterproof. Water doesn't flow through this foam. So this is an excellent material. Excellent, and polyethylene is a good RF material, so it doesn't disturb the RF at all. You put this over the slotted line, and it insulates and isolates the slotted line from the environment. So you can put this down 1-inch conduit. You can put it in PVC pipe and bury it in the ground. You can lay it right on top of a metal roof. You can put it in your flower garden, and it works just fine. The conduit, the open wire line now doesn't pay any attention and works just like it was out in open air. And I proved it, and I'm going to show you how I proved it. Oh, by the way, how do you make a long piece of it?
You just get some waterproof tape and tape lengths of this together. In other words, you're making yourself a kind of a new coax. You're making yourself an open wire line coax. Okay, here's the setup I use to test, to find out how different it would be if I took some of that ladder line inside of that foam insulation. And it's sort of like a pool noodle, although pool noodles would work for this too, by the way. I took a VNA. Many of you might have purchased recently one of these little nano VNAs. They're readily available on the internet. So I took a little VNA. It wasn't one of the nano VNAs. I've got a couple of those too, but this was a German VNA that I've had for quite a little while, and which can do several types of measurements. But a VNA is a 50 ohm device. So I had to make myself a balun so I could match it to a piece of 450 ohm transmission line. Took 10 feet of, which was just the length of one of those pieces of foam, and hooked it up to one side of the balun, and to the other side of the balun is hooked up to the VNA. I needed the balun so that the VNA is a 50 ohm device. The 450 ohm line is a 450 ohm device. So I needed a balun to make a proper match between the two of them. I made the balun, although I could have bought a commercial balun if I wanted to. Then at the other end, I put a short circuit. Why did I put a short circuit? To cause everything coming out of the VNA to be reflected back. In other words, I made an infinite to one SWR. Caused everything to be reflected back. I could have just opened the other end, and then it would have doubled the length of the line. But the short circuit was the easy way to do it. And then I made a measurement with the VNA called return loss. It's a standard measurement that you can make with a vector network analyzer. If you've got one of them, you can easily do it. It just tells you how much signal bounces off the other end. If your SWR is perfect, nothing bounces off the other end. If it's a one-to-one SWR, that's what you get when your SWR is one-to-one. Nothing bounces back. It all goes from your transmitter to your load and gets radiated if your SWR is one-to-one. But if your SWR isn't one-to-one, some of it gets reflected back. If all of it gets reflected back at a short, such as the SWR is infinite, then the return loss is 100%. So by using this setup, the amount of loss that I got in the line, the return loss was half of the return loss that I measured. That's how I was able to measure how much loss was in the transmission line. It was an easy way to measure loss in a length of transmission line, a shorted piece. And the 10 foot was simply because that was the length of the foam that I bought at the hardware store. It was also the length of the piece of 2-inch EMT conduit that I bought to use for testing. So that's the test setup. This was not a laboratory setup. I wasn't trying to get absolute laboratory figures, just to make a comparison. I took this simple setup, tried it in open air, and tried it in 4 or 5 different situations and compared the difference. And if I saw a lot of difference, then I knew this wouldn't work. But if I saw no difference, then I knew these were satisfactory places to use. Simple, pragmatic ham comparison, which I'll show you here now. Here's my balun, by the way. I just had some FT240 Mix 43, which are HF toroids, 2.4-inch toroids, and I used some speaker wire to wind myself, bifilar wind myself a couple of one-to-one choke baluns. And then I took 3 of them, and I hooked the primaries in parallel for the 50 ohm side, and then I hooked the secondaries in series to give me the 451. In other words, it's a 9-to-1 balun to give you the impedance match of 50 to 450 ohms. The 50 ohm side is hooked to the SO239 connector, and the 450 ohm side is hooked to the double barrel, double banana thing, which I hooked to the 450 ohm slotted line. to give me the correct match for the VNA on the left and the slotted ladder line on the right. And here are my four test situations. Not laboratory. This is not a laboratory setup. But if I saw a big difference in any of these, then I knew that I was barking up a hollow log, or hoo-hooing up a hollow log, as they like to say in the south of the United States. That's a southern expression, southern U.S. expression, like a hound dog that's found the rabbit up a hollow log and he's hoo-hooing up a hollow log. Common Southern American expression. Anyway, there's my on the left. You can see the foam with the slotted line inside of it, and the shorters at the other end, and the ballon here at this end, and the piece of coax leading over to the little VNA lying on the concrete. On the left, there it is on concrete, something that no respectable ham would do with open wire line. And then that's the VNA, and then the little coax leading off to my computer. And then there's the second one there on the right on wet soil. That's in the garden right next to the concrete. All of these are done out on my patio. And again, the short is at the other end. The wet soil is pretty much equivalent to burying the thing in the soil. And then I took the same setup and I put it on top of the cover over my patio, which is an aluminum roof. Again, nothing any respectable ham would do with open wire line, just out in the open. Then finally, I set the whole set up again, same setup, up on top of 2 chairs and 2 wooden stools to get it pretty much up into open air, which is where most hams think the only place you can run open wire line. And you can see a little bit of the open wire line coming out of the end of the foam tubing and the ballon again. So here are 4 different circumstances. The only one that most hams think is roughly correct, and 3 on the left, which most hams would think they should never do. How different was the half of the return loss when I measured it with the vector network analyzer? Here are the results. Those are the 4 curves that I got from 2 megahertz to 28 megahertz across the whole HF band. Now, what's the bump in the middle? Well, that's the resonant frequency of 10 feet of the transmission line. It's irrelevant. What's important here is the difference between the 4 curves that you see, the purple and the green and the brown and the black curve there. Those are the 4 curves of those 4 different conditions that I showed you in the previous program. How much difference is there? Almost none. All 4 of those circumstances, whether lying on concrete, buried in the soil, or at least lying right on top of the wet soil, which is like lying right in the flower garden, or over the top of right on top of an aluminum roof, or up on the stools out in free air, no difference, virtually no difference at all. In fact, as I show you in this slide, the open air was a little bit worse than when I put it through a piece of 2-inch steel pipe or conduit. The conduit was actually 1/10 of a dB better. But overall, the difference between all 4 of those was less than 0.2 dB. How important is 0.2 dB? It isn't. It shows you that you can use open wire line in all sorts of conditions that you would never think of using it. In conditions where you would only use coax before, with just this little bit of foam, you can use coax. You can use open wire line where only coax would have gone before. In fact, what essentially you're doing is making up a type of transmission line that you don't see much anymore. It used to be around in the early days of computers, and I still had a piece of it, and here's a picture of it. It was called Twinax. It was actually a twin conductor type of coax inside of a jacket, and that's essentially what you're building here when you're making this kind of foam insulated line. I got onto this several years ago, actually, or after doing this presentation, when I designed this flagpole antenna out in front of my house. This is my little mobile home that I live in. It's a 20-foot tall 2-inch diameter aluminum self-freestanding flagpole, and it has 2 insulators in it because it's a half wave. It's an off-center fed half wave. It's not a quarter wave. It has no radials. There's no radials. It's a half wave antenna. It has 2 insulators. The one at the bottom, which is insulated from ground, and then another one up at 4 feet. It's an off-center fed half wave, so it needs no radials. Because I had no place to put radials. Am I going to dig up my house and dig up my garden there to put radials down? No way. So I had to have a no radial antenna. So I made this 20-foot tall flagpole antenna, which has been very popular, by the way, and is being commercially sold by a company up in the northwest of the United States these days. And it's off-center fed by 450 ohm ladder line, which you can see just barely coming out at the bottom where the red arrow is. Now you see a little bit of it. And it goes into that same foam, which runs into my shack, which is just inside of my little house there. And it works just fine, lying right in my flower garden. So this is where I learned about the foam in the flower garden. In those days, however, at first I wasn't using the foam. I was using these spacers because the ladder line comes up inside of the bottom section of that flagpole. It's putting ladder line inside of metal pipe. I spaced it off with spacers. Well, that's fine. That worked fine, but I could have used that foam. I hadn't quite learned of foam yet when I built that flagpole, but the same principle works. Keep it separated from the environment and keep it dry. Well, it wasn't going to get wet inside of the flagpole. So, but lying in the garden is where I used the foam. Some of my readers sent me a couple of pictures here. Here's one of my readers using the foam inside of PVC pipe, and one of them burying it in the soil. Works just fine. So let me give you, now that shows you what you can do with open wire line inside of that insulating foam. You can use it where no open wire line has ever gone before, where coax is normally considered the only thing you can use. Let's close here now with a slight change of subject. I'm going to change gears here a little bit, but to give you something I think you'll find interesting. It's related. I'm going to take you on a little adventure that I took some years ago, and this is brief. We won't take much longer here. But this is a little closing extra. I'm going to take you to a place where open wire line is still king, because I found this most fascinating. This is to a museum, the Maritime Radio Historical Site Museum, north of San Francisco. Radio station KPH, which is a ship-to-shore station, the only one still existing in the United States. I don't know how many of them exist throughout the world. They used to be all over the world. When ships at sea used to go to sea and they wanted to communicate with the shore, send cablegrams to the shore, make arrangements and so forth, they communicated to the shore by CW, to ship-to-shore stations. They were along the coasts of every country in the world. Most of them are gone now. There's one of them still left in the United States. Recently, there were 2, but I think even the one on the east coast of the United States at Martha's Vineyard is gone now. But this is the only one still operating. It's a national park, actually, or national reserve anyway, in north of San Francisco. An old friend of mine who's now a Silent Key and I took a trip there, and it was a wonderful trip. And I think you'll like the images you'll see of this. It's a brief few images, but they use open wire line, which I think is a good example of where open wire line is still used. Here's a map of it. There's San Francisco Peninsula there, where San Francisco City is on a peninsula just between the ocean and the San Francisco Bay. The city sits right on the tip of the peninsula. Golden Gate Bridge crosses from the tip over onto the tip there, on the yellow area is the reserve, the Point Reyes National Seashore Reserve, run by the National Park Service here in the United States. And it has 2 sites separated by about 10 miles. One is a transmitting site, and one is a receiving site where they transmit on 500 kilohertz, the old marine ship-to-shore frequency. They still get occasionally a ship that'll answer them. Some of the developing nations of the world still run 500 kilohertz, and they still get a CW answer once in a while. They go on the air every Saturday morning at 9 o'clock local time, and can be heard on 500 and 470 kilohertz. I've heard them on both those frequencies, as well as 6 shortwave frequencies. And it's a fascinating trip for anybody that's ever in San Francisco to drive up there. The two buildings, the transmitters and receivers then were built by RCA way back in the 1920s, and they were using spark transmitters back in those days. Half million watt spark transmitters. You can imagine what beasts those were. Anyway, so we took a trip up there to visit that site. Here's the receiver site where the receivers are located. Transmitter sites was 10 miles away. They did that so that they could listen to themselves talk. And there's a telephone line between the two sites so that they can operate the station from 2 separate sites. And this is what the old building built in the 1920s. Here's my good buddy, who's now a silent key on the left, KE6YHI, and one of the trustees of the station. That's one of the 500 kilohertz transmitters. They also have 6 shortwave transmitters, which they put in later, built by Henry Radio, the people that built all the amplifiers, who built these 6 shortwave transmitters. Those are antenna tuners that come from the transmitters, and they feed 2,000 ohm open wire line. You can see them going out through windows there on the top of the building. So plexiglass windows feeding 500 shortwave frequencies out on open wire transmission lines out to the lazy H antennas that are out in the field. Here are the 2,000 ohm open wire transmission lines coming out through the plexiglass windows. Here's the early days of the station. That's the same building you saw earlier on shorter poles in the earlier days. They put them on bigger poles today. That's one of the 500 kilohertz antennas out there, and here's here's the open wire transmission line feeding the signal to it. Here's me. I hold a commercial telegraph license, so I can legally go on the air. So they actually let me send the daily bulletin out on 600 kilohertz and also on 6 shortwave frequencies simultaneously. So I got to send out their daily bulletin, which was about 50 words long or whatever it was, mostly just announcing the station. And but I could also hear myself coming back. It's the only time I've ever been able to be on the air on 18 kilowatts simultaneously. Was quite a thrill. Here's the trustee, Richard Dillman himself. They have a ham station there that also goes on the air at the same time. You can see the ham transceiver up there in the rack, K6 KPH. It's on the air every Saturday, 9 o'clock. It's the modern station there. A wonderful, wonderful visit. So now you too can go where open wire line has never gone before. Like the Star Trek Enterprise exploring some new planet, maybe you can make a run in open wire line that you never thought that you always thought you had to make in coax. It can be made in open wire line, and you can pick up a few dB. Here's my dog Lolly. She's a Shih Tzu, by the way. That's my email, w6nbc@gmail.com. And again, you can get these slides if you want them, w6nbc.com/slides. And that's it, folks.
Thank you very much, John. I certainly enjoyed that presentation. I see there has been 1 or 2 comments and questions in the chat. So I don't know if you know RG213 coax.
RG213, sure. Good coax, slightly better than RG8. Not quite as good as LMR 400, but good stuff.
Okay, because that was one of the questions, and I got it wrong. I thought it was slightly worse than RG or RG8, but anyway,
Or
I'm
maybe
now.
maybe it is. I don't know that. I thought it was better, but I'm not sure.
I thought they were very
I
similar.
spoke that one off the top of my head.
Yeah, I thought RG8 and RG213 were very similar, but absolutely RG LMR 400 really takes it. So commentary, very good, amazing, and thank you for a very good presentation. Those were coming through from there. John, I've got a question or two. Why does the moisture matter when this 450 ohm ladder line is actually insulated? It's plastic coated. Any thoughts
Well,
on that?
say that again. I didn't quite understand what you said.
Um,
Rephrase it a little.
okay, you mentioned moisture was a problem with the 450 ohm ladder line,
Okay.
but the 450 ohm
Why
ladder,
is it a why is it a problem? You say.
yeah, why is it?
Is that your question?
That is the
Why is
question.
water why is water a problem? Well, it's
Yes.
interesting. It has to do with the nature of the water molecule itself. Water molecule is what's called a polar molecule. Meaning it's not symmetric. The oxygen and the hydrogen atom the two hydrogen atoms and the oxygen atom don't bond together straight. In other words, the oxygen in the middle and the two hydrogen atoms aren't in a line. They're at an angle, and they share electrons. Any molecule does. The outer orbital electrons run around and share outer orbits. Yeah. It causes the molecule to be more positive on one side and more negative on the other side of what's called a nonpolar molecule. So when it gets into an RF field, which of course it does on the surface of a wire, it takes some of the energy of the from the wire to
Okay.
try to line those molecules up, whereas other molecules are nonpolar. For example, I do a whole talk on plastics where I really go into this in some depth. Some plastics like polythene or polypropylene are nonpolar. All the molecule is symmetric, so you can use it in an RF field and they do not absorb much energy. Whereas other plastics like PVC are polar and they absorb a lot of energy and they heat up. Nylon, for example, is a very bad plastic to use in an RF field because it's a very polar plastic. And I had a bad example. I tried using a nylon screw to pull a 3D printed capacitor together that I was using in a magnetic loop. And as soon as we put more than 50 watts of power, the nylon screw melted
Yo.
because of its dissipation factor. Whereas if it had been a polythene or polyethylene screw or polypropylene screw, it would have stayed fine. And it's due to the polarity of the molecule.
That is
Heat,
very interesting, John. I've learned something more now as well. And then my
well,
second one,
have me back and let me give you the lecture on plastics. It's a very interesting topic on what plastics to use and not to use when you're using them to build antennas with. For example, PC board is not really a very good plastic. The hot glue is not a very good glue to use when you're making antennas.
oh, that is interesting. Then, John, my second question before we open it up to the floor is interference. Right in the beginning, you mentioned coax was one of the positives of coax is interference. Do you see a lot of interference with the ladder line?
Well, if ladder line is properly matched at the end, the currents in the two wires are equal and opposite. Therefore, they tend to not to produce field. That's
Okay.
why they don't produce field. And so an open wire line, if it is properly matched, in other words, there's no standing wave in it, is really doesn't radiate.
Okay.
That's yeah, so if your open wire line, however, is not properly matched, meaning you've got a mismatch at the end, then the waves are out of phase, then you're going to have some radiation. Whereas coax will not tend to do that uh, as much as open wire line will do.
Okay, thank you, John. Right, anybody else got any questions for John? If you do, please just unmute and go ahead and ask your question. And
I guess we blew him out of the water.
No questions from me, but I'd just like to thank you for a great presentation. Learned a lot tonight, John. Thanks. I never even thought about the plastics variations aspect. Gee, so much to learn. You can never know everything.
Well, just book me for another talk and we'll give you the plastics one. That's an interesting presentation. You know, I heard years ago that PVC wasn't that good a plastic, but when I looked into it, I found they're right. It isn't, and neither are some other plastics. I'm a big 3D printer. I have a Prusa Mark IV 3D printer. Love it. Do a lot of printing of things. Many 3D printed objects around my house, and I use it to make antenna parts. You need to be careful with what plastics you use to print antenna parts. Some places it's no problem, but in other places, particularly where the plastic is in the RF field, and you got to watch out. Otherwise, the plastic won't tolerate power.
It is
so
interesting.
Show you how to do that and what plastics to use and not use.
We will have to look into that one as a future presentation. Thank you, John, because we just slap in the plastic into the 3D printer and we print and we use it. We forget about the problems that it might cause. Any other questions for John? I notice Ray has asked, is the stepper open wire line easily available? It can be obtained, I know, Ray, from our local flea market. A good person to talk to is ZS6JJK. Jack, he did import a lot of it and he was selling it. So the 450 ohm ladder line is available. I don't think it's as easily available as coax though, so be aware of that. Okay.
Yeah.
John?
You got to look a little farther to find it, but it is pretty readily available. And
thank you, John. Well, then I'd like to say, John, a very big thank you from the Sandton Amateur Radio Club and South African amateurs in general for your presentation this evening, for coming on and giving us insights and your sharing your intellectual knowledge with us. Appreciate it.
My pleasure to do so, and I'll say 73 to you, and we'll hope to see you down the log sometime.
73, John. Thank you very much. And to
all
everyone,
the best.
Thank you very much for joining us this evening, and I hope you enjoyed John's presentation. 73, everyone.